Mr. Wickens eating a salad will be healthy. Mr. Wickens eating a salad. So what do you do after you multiply polynomials? That's something that I often ask myself. And you should as well. You've multiplied them. What comes next? What do you do? Well, look right here. Look at this. You've been in this situation, we all have. You started out with something like 3 times x plus 2. We've all been there. It's okay. We're going to explore this a little bit more. Okay, you're just walking down the street and all of a sudden it's like, whoa. Did not expect to see 3 times x plus 2 right there, but I'm going to deal with it. So when you have 3 times x plus 2 right here, you remember, oh, right, the term that's outside the brackets, whatever it is, right here it's a 3, I got to make sure that it multiplies by every single term inside those brackets. So 3 times x, well, 3 and x, those are 2 different things. Yeesh, you got a number, you got a variable. We're just going to put them together. 3x. And then 3 times 2, okay, I can do that. 3 times 2 is 6, right? Okay, so we've been left with we've been left with 3x plus 6. Okay? And you're like, well, okay, that's all there is to it, right? But here's where I want you to use your imagination. Okay? Here's where I want you to use your imagination. Let's say you're walking down the street and you don't see 3 times x plus 2. No, ma'am, no, sir. You don't see 3 times x plus 2. You see 3x plus 6, and you're like, excuse me? I mean, 3x plus 6, that's a big deal. So, what can we do with this? Well, you might be thinking, I didn't really want to see 3x plus 6. I wanted to see that multiplication. Like, I'm more comfortable with seeing multiplication on the street like that, rather than just seeing all those terms right there. This is where we do what many mathematicians do, and we act strange, okay? But let's get that out of the way. What many mathematicians do is they do the inverse. They do the opposite, right? So we multiplied to get here. But maybe you want to take this and you want to go backwards. You want to do the inverse. You want to get back to where we started. That's what this whole unit's going to be about. At least the first part of it. So, looking at 3x plus 6, can we figure out, or if we want to go backwards this way, can we figure out what the heck we started with to get 3x plus 6, right? And maybe there's a lot of things that we could have done to end up at 3x plus 6. Whoops. Maybe there's a lot of things we could have done, but we're going to look at undoing the multiplication, right? So when you look at this, you want to think, okay, well, maybe I had something here. Let me move that over. Maybe I had something like this, and I multiplied something inside to get 3x. It would probably be 2 things because I see that I have 2 terms here. So I'd probably multiply whatever this is into the first one and to the second one. So if I multiply that in, I'm multiplying the same thing to the first term and I'm getting 3x, and I'm multiplying the same thing to the second term and I'm getting 6. So I should be able to take that same thing out of 3x and 6. Okay, well clearly I can't take an x out because I have x right here. But if I took x out of, like I'm trying to take something out of both, right? If I took an x out of this one, I wouldn't, there's no x right here, I can't take it out, okay? Let me clean up my scribbles. It can't be x. If this was x right here, then when I multiplied it in, this would have another x and this would have another x. Once I multiplied it in, right? But there's no x right here, okay? It's not x. Maybe it's, if it's not a, so it's no variable then. If it's not a variable, it's got to be just a number. Well, there's the number 3 right there. So maybe if I had 3 right here and it went in, I'd have 3, and then, you see this process that I'm doing? See, I'm a detective. I'm investigating. I'm trying to see what can I take out of both things to end up back there, right? 3x can be divided by 3, and 6 can be divided by 3 as well. So you're able to see that, oh, I can take a 3 out of both places. Okay, let's maybe start moving a little bit faster here, right? Let's look at another example. How about 4x plus 8, right? You can think, okay, well, if I wanted to think about what could multiply to get to that, maybe if I had, again, there's 2 terms here, so I have 2 things. There's only a variable in one spot, so it can't be a variable outside, but, well, I can divide this by 4 and I can divide this by 4. I'm thinking about division because that's the opposite of multiplication, right? Over here, on this side, this is all multiplication, so if I want to go back there, I need to divide, right? Because to go this way, I multiply, so to go backwards to here, I need to think about dividing. Well, both of those things divide by 4, so I bet that if I had a 4 out here, and I multiplied that in, well, if I multiplied 4 by, okay, x, I'd get 4x, and if I multiplied 4 by 2 would give me 8, right? Oh, but that, of course, that's the same thing as 4x divided by 4, that gives me x, and 8 divided by 4 is 2. Okay, so basically, if I just divide that side by 4, I'll get what I should put in the brackets there, right? Okay. See what I did there? See what I did there? I can't take a number out of both of those. I can't. Because there's no number there, right? I have 2 terms again. So something out front would have to multiply into both of them. Can't be a number, because any number I put out here would give me a number at the end, which I don't have. Okay, so, well, I have an x in here, and I have an x here. I only have one x here. I have 2 x's here because I'm squaring, and I have x squared. Okay, well, let's try taking an x out, right? Okay. Take an x out. Well, x times x would give me x squared. X times 3 would give me 3x. Okay. What we are doing when we figure out what this thing is, this number out front, is we're going to use this term that we've talked about already, this GCF, the greatest common, it's fun writing it this way, factor. The greatest common factor. The greatest common factor. What is the biggest thing that can be factored out of a number of things, right? Because if we had 6 and 12, the greatest common factor, you know what, let's say 6 and 9. The greatest common factor for both of those 2 things is 3, because 3 is the biggest thing that can divide 6. 6 can be divided by 3, and 3 is the biggest thing that can divide, it's the biggest thing that can divide them both. The biggest one thing that's the same between the 2 of them, right? So what we're doing is we're actually looking for the greatest common factor between now these 2 terms, and we're including the possibility of that greatest common factor being a variable, which it is in this case. Because the biggest thing that we can remove from both of these terms, the most we can remove, is an x. We can divide this side by x, and we can divide this side by x, and we can't divide it by anything more. So we're going to start to include the possibility of x, or a variable, as being the greatest common factor. And when we pull that x out, when we divide by it, we see that this thing out here is the greatest common factor between those 2 terms. So we're kind of phrasing it in a little bit of a different way, right? But really the main goal of this is to be able to see, can I go backwards from where can I start at the end and go backwards and end up at a multiplication of 2 things, right? One last example that I can do is I can kind of combine the things that we've been looking at. What if I had, why don't I go back to the first one, 3x plus 6, right? 3x plus 6, but I'm going to make it a little bit more interesting, and I'm going to say 3x squared plus 6x. So this is kind of a combination of 3x plus 6 and x squared plus, what did I do? 3x? It's kind of similar. It's kind of similar because I got x squared and x here, and I have x squared and x, but then I have 3 and 6, and I have 3 and 6. So it's kind of similar. I kind of wanted to try and combine those two different situations. So the reason I wanted to do that is because when we look at this, what can I pull out of both things? Well, I have a 3 here and I have a 6 here, so I can divide this side by 3 and I can divide this side by 3. So I could take out a 3, and this would have to be x squared, and this would have to be 2x, right? Confirm for me. If I multiply 3 times x squared, I get 3x squared, and if I multiply 3 by 2x, I get 3 times 2 is 6. Okay, good. But maybe some of you have noticed, right? Look at this. Can I still pull something out of x squared plus 2x? Well, there's still, why don't I use a different color? There's still an x there, and there's still an x here. There's 2 x's on this side, right? So I could pull 1x out at least, because I have 1 here. I can only pull out 1 from both terms, because I can't pull out more from this side. I can only pull out 1. But I can still take out an x, and I could still take out, rather than x squared, I could take out an x there and be left with this, right? So let me rewrite that. 3x times x plus 2. If I multiply that in, 3x times x is 3x times x, so x times x, that's x squared. 3x times 2, 3x times 2, 3 times 2 is 6, x just stays on the side. Oh yeah, for sure. This is the same as this. So, indeed, oh, I missed it. Indeed, this is the more complete thing. This is the most we can take out, and that's what we're going to be interested in doing, is what is the most that you can pull out? What is the, again, greatest common factor between those two terms? What is the greatest thing you can pull out? Now, it's okay if you don't pull everything out the first time. As you saw what I did right there, I pulled a 3 out, and then I was like, oh, I can still pull an x out, and I did that, right? Or you could maybe see from the very beginning, oh, 3 and x exist in both places, so I can pull them both out at the same time. Either way is okay. But what this is called, what this is doing, if we had just been looking at multiplying polynomials, that's what we were just looking at, now we are looking at factoring polynomials. So when we go backwards from multiplying, if we multiply to get forward, if we go backwards, we are factoring polynomials. And the way that we're going to start by doing that is we're just going to pull out as much as we can from each term to get back to something like this, right? I'll leave you with this challenging question. How could I go backwards from this? I'll give you a hint. There's your little challenge, little detectives. See if you can figure that out. It's not going to be the same as what we were just looking at. It's going to be a little bit different. You're going to have to be a detective in a different way. But you can still figure it out by being detectives. Oh, right. I was right in the middle of my salad. Okay, I'll let you guys go. I'm gonna eat my salad. You guys have a good night. I'll talk to you later, and I'll